Hello, Dr. Data Science here to teach you data science methods and tools today, tomorrow, and beyond. In this video, I'm going to show you how you can visualize regression models in less than 10 seconds. You heard it right, in less than 10 seconds using Seaborn in Python. If you find this topic useful, please don't forget to like and subscribe. In general, regression is used to quantify the relationship between two or more variables. Therefore, regression has a lot of applications in different areas. Sometimes we want to estimate a simple relationship between only two sets of observations of variables. So in this case, we have one independent variable, which we call it x, and one dependent variable, which we call it y. And the training data set consists of n input-output pairs, which we show them by x1, y1, x2, y2, up to xn, yn. And given this training data set, our goal is to infer the underlying function f that relates the output to the input variable. In a previous video, I discussed the basics of linear regression and how you can find the equation of a line that fits the entire data set. I also discussed how to use linear regression from scikit-learn to train regression models, which is very straightforward. You just need to import linear regression, initialize the model, use .fit on the training data, and this will give you the coefficient and intercept term that you're looking for. Okay, so now let's recreate the example that we had and use Seaborn to just draw the regression line in less than 10 seconds, and also probably you can do it in less than 5 seconds. So in this case, we are going to import numpy as np, and also we have to import Seaborn as SNS. Obviously, these names are arbitrary. You can import Seaborn as any name that you want, but it is common to use SNS. And also we are going to import matplotlib.pyplot as PLT for visualization purposes. So here we have two sets of observations of variables. One is the input to the function and the other one is the output. The input here is a set of 20 random numbers that are uniformly distributed between 0 and 3. And the output variable is designed to be linearly connected with the input. So if you look at the equation, we have 2 times x plus 3, and then we have some noise level to just make sure that we don't have a trivial solution. Now here is the magic. You can just use sns.regplot, and you have two important parameters here, x and y. So x is your independent variable and y is your dependent variable. So here we give the input variable to x and output variable to y. You want to specify the color of this line, you can do that, and that's it. You have such a nice plot here that we have the collected data points and the regression line. And if you're wondering the sort of like the shaded area, that corresponds to the 95% confidence interval, meaning that how confident we are about this regression line that fits the entire data set. Okay, so now let's look at some real data set. Seaborn comes with some standard data sets, and one of them is this data set called tips, which is a data frame, has these different columns, and the idea here is that we want to find the correlation between tip and total amount of bill. And obviously this data set or this data frame contains other information, pieces of information too, such as whether each customer is a smoker or not, and also gender. And in this case, instead of using sns.regplot, we are using sns.lmplot, because in this case we can just give the name of the data set as the third argument, and then we can just specify the column that is considered to be independent variable and the column that is considered to be dependent. So here the total amount of bill is our input and our output is the amount of tip that each customer has paid. Therefore, using Seaborn here will give us this very informative plot that shows the correlation between these two variables. And again, just to emphasize, you could have used sns.regplot that we used in the previous slide, but the nice thing about sns.lmplot is that you can give the name of the data frame and then specify the column names as independent and dependent variables, which makes it much easier when you have multiple data sets that you're working with at the same time. So now we are going to work with another data set. And when we visualize these data points, we obviously see that a linear regression model does not capture the underlying structure of the data, because obviously this data set has some nonlinear structure. So therefore, if you want to just use sns.lmplot the way that we used before, we see that we will find a line that will go through the data, but obviously this line doesn't explain the data very well. And this is problematic, and that's something that in machine learning we call this underfitting, meaning that the training model that we have doesn't capture the underlying structure of the data. So the question here is that how we can fix this in a simple way. So one idea is to use sns.lmplot, but we can specify the order parameter here, which this is, you can think of this as the order of the polynomial model that we are feeding to this data set. So here order equals to 2 means that we are going to use a degree 2 polynomial. And obviously we can specify the color of the line and also the size of these circles here for data points in our scatter plot. So we have a lot of options in terms of customizing these figures. And now, as you can see, this new regression model fits the data very well. Another nice feature of Seaborn, which comes very handy, is that we can specify the relationship between two variables as a function of a third variable. So in that tips data set that we had, if you remember, we had different columns. So two of the columns correspond to total bill amount and tip amount. But also we had another column which was called a smoker. So now we want to see if the correlation between total amount of bill and tip is different for people who are a smoker or people who are not a smoker. So here we can use again sns.lmplot, and we give the two independent and dependent variables, and now we use this another input parameter which is called hue, and this means that we are conditioning on this column of the data frame. And obviously this column has only two types of variables in it, either yes or no, so it's a binary case, and this will create such a nice figure for us that shows the correlation between tip and total amount of bill for people who are a smoker and not a smoker. Finally, we will explore another built-in function in Seaborn, which is called sns.jointplot. And similar to sns.lmplot that we had before, this built-in function accepts two variables, one dependent and one independent variable, and also the name of the data frame. But also, in addition to plotting the regression line, this function will plot the histogram or the distribution of each variable, as you can see in this figure. So this is very helpful when you want to both look at the correlation between the two variables and also understand the distribution of each variable. I hope you found this useful. Thanks for watching.